Welcome to Massive Open Online course on fluid flow operations. In this lecture, we will discuss about the multiphase flow phenomena and its application, and this will be a module 12, and under this module we will discuss the introduction to multiphase flow and also some hydrodynamic aspects of the multiphase flow. Some typical example of multiphase flow will be discussed in the subsequent lecture with its application. And here we will try to just introduce what is that multiphase flow here in this lecture. So, we have already discussed the phenomena of single phase flow, whether it is laminar flow or turbulent flow, or how it will be behaving with the phenomena of what is that, is there any drag force or any lift force or not. Even there are several I think governing equations that we have given for discussion of single phase flow in different type of conduits, and also we have discussed the flow measuring devices for the measurement of flow rate of this single phase flow in the devices. Now, in this module we will try to discuss that instead of single phase flow, what should be the multi-phase flow system. Except single phase flow, there may be more than one phase. There are several applications of this multi-phase flow in our chemical, even biochemical industries, and also other several operations there. This more than one phase is really applicable there. And in this case, you will see then we will then discuss what should be the actually basic understanding of that multi-phase flow systems. You know that if we are considering that there will be more than one phase, then only it will be multi-phase flow, but there should be a certain definition of that. Of course, that we can define in this way of this multi-phase flow, that it will be a simultaneous flow of materials with different states or phases like gas, liquid or solid. So, in this case gas, liquid, even combination of gas, liquid, combination of liquid, solid or combination of gas, liquid, solid simultaneously will be flowing in a system for a particular process. So, in that case based on this multi-phase flow phenomena, the process will be designed, and then accordingly what will be the performance of the process and what will be the yield of the process, that will be actually calculated based on the flow phenomena of this multi-phase flow. Now, this we can define this multi-phase flow in other way. Sometimes you will see there will be more than one phase, but there may be miscible to each other. So, in that case you have to consider that there will be two components of that particular single phases, but sometimes you will see that there are single phase, but there will be immiscible to each other. In that case also it will be considered as a multi-phase flow. Sometimes the different chemical properties will be there, and the same state or phases, that is why they may be the immiscible to each other, like kerosene and water, both will be flowing through the pipe. In that case you will see they will be simultaneously flowing, and they are immiscible to each other. So, in that case those flow will be considered as a multi-phase flow, and the separate phases simultaneously flowing, that will be multi-phase flow. Even materials with the different chemical properties, but the same state or phases, then it will be called as multi-phase flow, like liquid system there, such as oil droplets in water, like this. And you will see whenever this combination of these phases like gas liquid or liquid solid or gas liquid solid simultaneously, or liquid that is immiscible to each other, whenever it will be flowing, then you will see one phase will be in a certain manner whenever it will be flowing in a conduit. So, upon these two phases, one of the phases will be continuous, while the other phase will be dispersed. Like if you consider that there will be a gas is flowing through the liquid. like gas cannot be flowing in a column as just in a just on a what is that, in a single phase in such a way that it will be continuous. Yeah, it may be there sometimes. So, in weighted column, in the core of the column there will be a flow of gas, whereas adjacent to the wall there will be a flow of liquid. So, there will be a flow. So, in that case both phase may be continuous, but generally you will see the immiscible, that is which fluid will be lighter than other, that fluid will be dispersed in a continuous liquid. So, whenever gas is dispersed in a liquid as a dispersed phase of bubbles, then you will see the flow will be a multi-phase flow, and in that case gas will be as dispersed phase and liquid will be continuous phase. So, whenever multi-phase flow phenomena will be considered, you will see one phase will be continuous, another phase will be dispersed. Like a solid and air, like suppose particulate or solid particles is flowing in a atmosphere. So, in that case particles are dispersed, whereas gas or atmospheric air will be as a continuous phase. Now, some examples here you will see that gas bubble in liquid, sometimes liquid drop also in a gas. Whenever you will see in a spray column in chemical engineering operation, you will see for absorption purposes, you will see the liquid will be sprayed over the column there, and from the bottom of the column there will be a gas will be flowing up. So, in that case liquid droplet will be spraying in the continuous air. Also you will see maybe if there is a kerosene and water flow rate, you will see the kerosene is lighter than water. So, in that case kerosene droplet will be moving through the continuous water there. And also solid in liquids or solid in gas, those are will be the multi-phase flow phenomena, and in this case one phase will be the continuous and another phase will be the discrete or dispersed phase. So, we are having the definition here, what will be the multi-phase flow phenomena. You have to remember that materials with the different states or phases, it will be called as multi-phase system. There may be more than one phases like gas liquid, even liquid solid, gas liquid solid. So, 2 and 3 phases generally is considered as a multi-phase flow system. So, in that case one phase will be of course discrete, another phase will be continuous. So, any phase you can make discrete or dispersed, and another phase should be what is that, continuous, but you can make it reversed way also based on your system design. Now, here see, then we can classify this multi-phase system as here what is that, gas liquid, liquid solid and gas liquid solid. Even in the 2 phase where we can categorize it into 2 phase and 3 phase. In 2 phase you will see gas liquid, liquid solid and gas liquid. Even you can have here liquid and liquid also, liquid liquid, though it is one phase, but since its physical properties are different from each other. So, it will be considered as a multi-phase flow. And here 3 phase flow, it will be there, what is that, gas, liquid and solid. See here on the figure it is shown that in a continuous gaseous medium solid particles is dispersed there. So, it will be gas solid operation, one 2 phase flow. And in this figure you will see there will be a continuous liquid phase, and whereas liquid and gas will be dispersed in the continuous liquid phase, like a slurry bubble column reactor. In that case solid particles, solid and liquid will be made as a slurry, and in that slurry liquid will be continuous and solid will be dispersed in the liquid, and on that slurry system gas again will be dispersed through the distributor as a dispersed phase of bubbles. So, that is why this 3 phase will be considered as gas liquid solid flow and phase, and it will be considered as the slurry bubble column reactor. Now, gas or liquid acts as a continuous, and gas or solid acts as a discrete or dispersed phase. Generally it is considered in the 2 phase or 3 phase systems. Now, here see a video that some from our experimental condition, and even in our laboratory. See, this is one type of bubble column reactor, this gas liquid operation here. See, gas is dispersed in the liquid continuous liquid medium as a dispersed phase of bubbles, and see how it will be moving up from a bottom through a spot jar through a distributor, gas distributor. Here this is gas distributor. So, from this gas distributor, gas is just coming out at the dispersed phase of bubbles. So, here it will be called as gas and liquid flow. It is one type of multi-phase flow system. Even in these systems, you will see you can use that slurry system also, because here if you are using that liquid as a slurry, they are just mixing some solid amount of solids there, and then you make it slurry, and then if you are supplying the gas in the slurry medium as a dispersed phase of bubbles, then you can consider it as a slurry bubble column reactor. And here another examples in this figure, you will see there will be a operation of gas and liquid flow. So, there you will see sometimes for drying purposes or roasting purposes, even sometimes you will see there will be a adsorption purposes. Suppose gas is adsorbed to the solid bed, then in that case gas and solid will be dispersed in the column, and then you will see there will be a adsorption from the gaseous medium to the solid medium. And in other applications, like if you consider that our coffee bean, you will see they are what in our daily life we are taking the coffee. In that case, you know that how this coffee is being roasted, and you will see the green coffee after roasting it will be becoming a brown coffee, and after that it will be making as a dust, and then that is powder, then you are mixing and you are making the coffee what is ready for you. Now, in this case how this coffee, green coffee, it is being roasted and after that it will be making a powder. Now, before going to make it powder, you have to roast it. Now, what is that operation? Roasting operation, and it is of course the multi-phase operation, because here two phase systems are working. One is air as a gas, another is what is that coffee bean as a solid particles. Then you will see hot air to be supplied at a certain temperature to fluidize that coffee bean, and then you will see after a certain period of time, then you will see continuous operation of this supplying of this hot air. This coffee bean will be converted to the roasted coffee bean, it is brown color. You will see this video, then you will understand how this is the green, you will see this green coffee bean. This green coffee bean is taken in a column, and in this column you will see from the bottom there will be a supply of hot air at a certain temperature, and you will see that how coffee bean is being actually fluidized whenever that hot gas is supplied or hot air is supplied there. Here starts of roast here for 3 minutes, you will see how it is coming there. Start of roast 3 minutes at 310 degrees Fahrenheit. Then you will see how this coffee bean, this is see green, after a certain time you will see it will make brown color, that means here it will be roasted. See here, so hot air is just roasting this coffee bean and making it brown color, that is simply frying. So, this is a simple two phase operation of gas and solid, and after a certain times you will see all this green coffee will be becoming a what is that brown color coffee, and after that it will be made at what is that dust or powder, and then it will be used for your coffee. So, this is one type of operation of this multi-phase flow. So, it is called two phase flow, that is gas and solid. You will see another here one video here, you will see there is another operation, that is three phase flow, gas, liquid, solid. You will see how gas is distributed from the bottom of the column, whereas this gas is dispersed as a dispersed phase of bubbles in a slurry medium, that is liquid and solid mixture. So, liquid and solid mixture, it will be called a slurry. So, in this slurry the gas is supplied from the bottom of this column as a dispersed phase of bubbles. So, this type of operation here you will see the Fischer-Tropsch synthesis for a particular temperature, then how the different gaseous products is made from the liquid, then how at a particular catalyst, then this type of operation will be called as Fischer-Tropsch synthesis. This is a fluidization operation, and in the energy section in petroleum industry this type of operations is used. So, this type of we have already discussed in I think other courses, that fluidization operation there we have discussed all those operations there. And here another important, this slurry bubble column reactor, here see how bubbles are forming from the bottom and it will be continuously moving up, and then there will be certain process for products they are in industry they are using. You will see some examples of gas liquid operation, like suppose carbon dioxide gas is to be absorbed in a liquid medium. So, how to actually operate and how to get this product of the reduction of the carbon dioxide from the atmosphere by this operation. So, this is one type of multi-phase flow system. In that case, you will see carbon dioxide gas to be supplied in a carbon dioxide gas to be allowed to pass through this sodium chloride solution as it is first phase of bubbles. So, that bubbles will be forming. In that case, bubbles will whenever it will be dispersing in the liquid form, liquid medium, then there will be a formation of interfacial area between bubble and liquid. So, through that interfacial area there will be a transfer of carbon dioxide molecule to the liquid. So, this is one type of mass transfer operation for this absorption process. So, this is called two phase flow operation. This is physical processes. Even other processes also you can see some reactions also. If you suppose example, as an example, if you want to do the advanced oxidation there in a bubble column, you can also do. In that case you will see, suppose if you want to degrade or what is that oxidized that pharmaceuticals products, or suppose phenolic compound, organic compounds into its derivative, then you can use ozone gas. That ozone gas as an advanced oxidation, that ozone gas as a ozone bubble through in a bubble column reactor through the distributor, then you will see there will be a reactive mass transfer, and also reactions as well as mass transfer will be there. So, this type of operation, that is called what is that two phase, that is in reactive two phase flow. So, this type of operation are being done in wastewater treatment, even some other particular product to obtain that product. Even in slurry bubble column reactor also you will see that if you want to make suppose chlorobenzene or benzene chloride, you can say. So, in that case, so what you have to do, in the benzene liquid medium you have to supply the chlorine, and also you have to use some catalyst there. So, in that case catalyst and the liquid, that will be slurry, and then slurry medium, if you supply the chlorine gas, you will see there will be a reaction, and at a certain temperature and pressure you will see there will be a product. So, this type of operation to make the chlorobenzene, this slurry bubble column reactor is used. Even start tank reactor also, that is sometimes for gas liquid and catalyst particles slurry column also it is being used. Their gas is supplied from the bottom or some other means as it is first phase of bubbles, and you will see there will be a formation of interfaces through which there will be a reaction and mass transfer there. So, this type of operation is the multi-phase flow operations. Also you will see in flotation column in mineral industries, one of the very important process for which the separation of the what is that particles, or you can say beneficiation of the particles, that is mineral particles in the what is that flotation column. There also this is three phase operations. Some you will see that ore particles, or suppose coal beneficiation, coal particles will be actually you know that synthesized, or gas will be produced from the coal particles there. and different gaseous products can be used by what is the combustion of coal. So, that type of operation also it is two phase flow, that is gas and solid. And you will see in flotation column, you will see coal, suppose you want to reduce the sulfur from the coal, you have to actually fluidize that coal particles by what is that, you know, that by ozone gas or some other gases, so that sulfur can be converted to some other what is that compound, chemical compound, and so that you can easily separate that compound. So, this type of operation is called three phase flow system. Even for separation of the particles in flotation column, if you allow the gaseous or air bubble from the bottom in a surfactant medium or frothing agent or flotation column, you will see there will be a separation of the particles from this mixture of different particles, and this type of operation is called that three phase flow. So, the multi-phase flow systems, those are applications. So, any real process, any chemical engineering process or biochemical processes also, they are also use this multi-phase flow system. Anyway, that single phase flow may not be there, there may be mixture of phases that will be operated in a particular process. So, whenever we are talking about that multi-phase flow system, there are several applications in the real that is practical life, that whatever products we are getting, all those products are coming through a process, and that process may be of course, there will be a process that is involving that more than one phases. So, multi-phase flows, several applications in chemical, biochemical, even processing, civil engineering also they are operating. Suppose you will know that operation of the soil, that soil mechanics, there also you will see that there will be different components of the soil particles and how to process that soil to get its different types of products there also it is. And also removal of contaminants from the what is that soil that you can have by this multi-phase flow operations with a certain processes. And so, this is now basically what are those combination of that gas, what are the different operations. Let us have some idea of that, two or more than four phases here, one by one. Let us consider that gas system, there is a operation of gas and gas, that is both two gases will be used simultaneously for a particular processes. In that case, gases are used as both primary and secondary fluid here, that is one phase will be continuous, another phase will be discrete. Now, sound waves travels faster through helium than they go through regular air, because helium is less dense than what is that regular air. So, in that case helium gas will be what is that will be forming a helium gas bubble in a air system. So, you will see there will be a formation that is discrete, helium gas will be discrete particle as it is in the air. So, this is one things. And another that sulfur, suppose hexafluoride, the SF6 is a gas which is 6 times heavier than air. So, this is what is that this is immiscible to gas system. And if you mixed this sulfur hexafluoride with argon, and this mixture of this sulfur hexafluoride and argon, that can be used in that insulated windows. And also this sulfur hexafluoride is used in the metal industry, for example, when casting magnesium there. And also eye surgeons use sulfur hexafluoride as a cooling agent in the operations, and it will be mixed with air, and this mixture can also be used as a fire extinguishing agents, because it is non flammable and cooling agent. So, this type of operations, some examples that how these gas systems are working. So, this is one type of multi-phase flow system. Now, gas liquid flow systems, let us see that what is the example for that. Now, in this case gas is used as a dispersed phase and liquid as a continuous fluid, which are most important form of multi-phase flow and is found widely in industrial applications. Now, some applications like here that absorption of gas in liquid to remove it from gaseous mixture, and removal of carbon dioxide, removal of nitrogen dioxide, even hydrogen sulfide from the polluted air in solvent, that is one important operations for the absorption. So, this is one type of gas liquid flow operations, that is multiphase flow operation. I have already told that there will be some ozonation system. So, you will see the ozonation of arsenic or ammonia or dye in water, that is you can say for the treatment of the water having this arsenic ammonia, then you have to ozonate it or advanced oxidized it, so that you can remove the arsenic or ammonia from the water. So, this is also one type of gas liquid operation. Even distillation process, the heart of the chemical engineering process in refinery industry, you will see whatever oil products we are getting after refinement of the crude oil, those are actually basic processes called distillation processes there. So, by distillation process we are getting different type of products of gas, even heavy, light or different whatever you know that mobile, kerosene, all those products that we are getting by distillation process. There also it is 2 phase processes, even 3 phase processes are there. Also you will see application of gas liquid chromatography to analyze of liquid petroleum reactions there, and also you will see gas liquid reactions like industrial gases like oxygen, hydrogen, carbon monoxide, carbon dioxides are widely used for synthetic processes in the chemical industry. So, from these you know that oxygen by oxygen, hydrogen, carbon monoxide, there are several products can be synthesized from these gases, that is obtained based on the gas liquid reaction. So, these are called reactive 2 phase processes of gas and liquid system. Now, another here liquid and gas system. In this case liquid will be a discrete fluid and gas will be continuous fluid. So, this is 2 phase flow. Here again in spray column you will see the liquid is sprayed in a gaseous medium for the absorption of gas. Even spray towers can be very effective in removing pollutants if the pollutants are highly soluble to liquid here. Even spray towers are used to remove hydrogen chloride gas from the tail gas exhaust in manufacturing of hydrochloric acid. This is another one important example. In the production of superphosphate, that is used in manufacturing fertilizer, that is silicon, in that case silicon hexafluoride and hydrogen fluoride gases are vented from the various points in the processes. This is one type of liquid gas operations, so multi-phase systems. And also the spray towers also used for odor removal in the bone metal and you know the tallow manufacturing industries by scrubbing the exhaust gases with the solution of potassium permanganate. So, this is one type of 2 phase systems of liquid gas. So, this is also called the multi-phase flow operations. Now, let us see that how these gas and solid systems are used for several chemical and other processes. Now, in this case there will be 2 processes, one is physical process, another gas solid reactions processes. Here you will see some drying of particles there, hot air to be supplied through the wet solids, so that at a particular temperature it will be fluidized in a hot air medium or hot gas systems, then the particles will be dried. So, this is one type of 2 phase system gas solid operation, like coating of surfaces, some solid particles to be coated with some other polymeric substances. So, in that case you have to fluidize the solid particles in a spray system, so that the particles will be being coated by that other materials. Even granulation process is also one important process where the particles may be growing from this what is that molten to the particles there. So, like in urea production, you will see the molten urea will be sprayed through a spray nozzle in a column, and it will be sprayed in a what is that cooling gas, so that molten urea will be converted to the what is that granular urea there. So, this is also one type of 2 phase flow system, that will be gas solid operation. Heat treatment process, annealing, quenching and also filtration, blending, classifications, all those operations are physical processes of this gas solid operations. Now, you will see roasting of ores, even zinc sulphide, copper sulphide, nickel sulphides, etc. In that case, for this type of production, you will see this gas solid reactions, this is gas solid operations will be there. Combustion and incineration of the coal, gasification of the coal, coking and pyrolysis or carbonization, even calcination process like limestone calcination, phosphate calcination, aluminum hydroxide production, there all those operations are basically gas solid reactions are there. So, multi-phase systems of gas and solid. Fluorination of uranium oxide, even you know that fluid coking, reduction of iron oxide, even catalyst regeneration, all those operations are gas solid operations. Now, let us have an example of liquid systems. Suppose liquids are used as both discrete and continuous liquid here. Suppose one example I am giving, suppose if you want to extract or remove what is that acetic acid or propionic acid from the waste water or some water where this acetic acid are reached there. So, you have to extract those acetic acid, what to do? So, what you have to do, this acetic acid or propionic acid reached to water to be in contact with some other organic solvent like you know that decanol, or you can say that paraffin or kerosene. You will see if you allow this paraffin or kerosene in that in this continuous liquid that is reached with that propionic acid, then what will happen, you can extract that propionic acid from the water to the what is that decanol or what is that paraffin or kerosene what is being used there. So, in that case the liquid operation will be there. In this case this paraffin or what is that kerosene or decanol, all those will be lighter than water. So, in that case this lighter liquid will be what is that dispersed in this continuous water. It will be as a drop of what is that or droplet of paraffin or kerosene or decanol, which one you are using, that is immiscible liquid will be passed through that continuous liquid as a dispersed phase of droplet. So, in that case this acetic acid or propionic acid to be actually extracted from that liquid to that paraffin. So, in that case there will be mass transfer of this propionic acid from this liquid to the paraffin. So, this is what is that mass transfer operation by which you can remove that acetic acid or propionic acid from that water to the paraffin. After that you can boil it, that paraffin or propionic acid, then you can easily separate those acetic acid or propionic acid from the paraffin. And so, this is the separation processes that is liquid separation processes. So, one solvent will be used that will be immiscible with the water, and then from the water you can easily separate those components. So, this is liquid multi-phase systems. And other applications like used for flow of emulsion of oil and water in pipelines, and different types of contactors like packed column, pulsed columns and starred tank reactors in various applications also are being used this liquid operation, and also extraction of organic contaminants from wastewater that I told here that. So, these are the several applications of this liquid system. Now, liquid solid system, these are also one important operations where the solid particles will be dispersed in liquid. So, in this case like hydraulic conveying of solid materials to the liquid, even slurry flows cover a wide spectrum of applications that range from the transport of coals and ores to the flow of mud. And in crystallization process, that solids are suspended in the liquids. In that case, how the what is that organic compounds or solid particles are actually suspended in liquid in the crystallization process, and this mechanism. And the flow of liquid through a solid is another example of porous media flow there. So, you will see in the porous media, suppose some liquid components to be actually extracted and it will be supplied through the porous media. So, that to get the more contact of that other solvent or other liquid. So, it can easily be even some liquid suppose components, some contaminants to be adsorbed on the solid particles, then you have to supply that liquid through the solid particles, then it will be liquid solid operation. Now, these are all two phase systems, that is gas liquid, gas solid, even liquid liquid, liquid solid. Now, what about the three phase system? Some examples like here, what is the gas, liquid and solid system, like performing of gas liquid reactions in presence of solid materials like catalyst. In the mineral industry, you will see fine solid particles are separated by the flotation techniques in column. So, this is one of the important processes in mineral industries, and these are gas liquid solid operation. Other applications like catalytic cracking, hydrotreating, hydroprocessing, even biochemical processes, cultivation of microorganisms, all those are three phase systems operations. These are all the heart operations, or you can say that main important operations in the chemical industry, where you are getting different types of several products in our daily life what we are being used. Gas liquid liquid, another important three phase systems there. In this case, very common flows of oil, water, natural gas, that is found in the condensation or evaporation of the immiscible liquid mixture there. So, this is gas liquid liquid system. Even solid liquid liquid system, in pipeline you will see if sand is mixed with oil and water, the three phase flow is very important there. So, these are three phase systems. And have you heard of the four phase systems? Any examples of four phase system? Yeah, there is also one important process that is called as the four phase systems, like liquid liquid, gas, solids. Suppose in freeze desalination process, what will happen, that when butane liquid is added into the saline water, that will result the isocyanous. So, in that case, this type of operation is called, what is that, liquid liquid, gas, solid. In this case, system is a mixture of butane, liquid, water, ice and the butane vapor. So, these four phases will be there in the, what is that, system. So, that is why this is called that four phase system. Now, question is that all those operations regarding this multi-phase flow systems that you are having. Now, what to learn or what more components you have to know for the process of these multi-phase systems. So, that is why suppose if any processes that is involving this multi-phase flow systems, then what you have to do, whether you have to do design, how to design that multi-phase flow unit based on the multi-phase flow phenomena, then only you will be able to make the product by a certain process in that particular unit. So, you have to know the proper design of efficient multi-phase unit based on the knowledge of multi-phase flow systems, multi-phase flow behavior. Till now, whatever we have discussed up to this lecture number 29, we have discussed all those operations based on the single phase flow system. So, you have to know something about the multi-phase flow systems also, multi-phase flow phenomena, whenever there will be a process, how this multi-phase flow will be behaving, and based on that flow behavior, how the product of that multi-phase flow processes yielded. So, in that case, some components of that multi-phase flow system you have to know. Though there will be no more details of that, but we will try to discuss in the subsequent 2-3 lectures the some basic aspects of that basic phenomena of the multi-phase flow system here. And it will be several courses for this multi-phase flow operation with the examples, but here still we will try to know something fundamental of that multi-phase flow system. Now, to know that multi-phase flow systems, you have to know some hydrodynamic parameter or hydrodynamic characteristics of that multi-phase flow systems, like how this whenever 2-phase flow or 3-phase flow will be flowing through the conduit or pipeline or in a column, what will be the regime, what will be the pattern of the flow, that whether it will be that is bubbly flow, or it will be slug flow, or it will be a stratified flow, or it will be a churn turbulent flow. There are the several different types of flow patterns will be there. We will be discussing in the next lecture that different types of flow regimes or different types of flow pattern of these 2-phase systems. This is happening because whenever you are simultaneously passing this gas and liquid, you will not see that the single liquid will be separately flowing and liquid only gas will be gas and liquid both will be separately flowing. But whenever there will be a mixing of these 2 phases, then you will see there will be certain phenomena of that 2 phase systems or 3 phase systems. So, that is called the flow pattern, how it will be there. Maybe sometimes you will see some forms whenever gas will be flowing through the liquid as a dispersed phase of bubbles in a certain flow rate of the gas, in a certain flow rate of the liquid in a continuous medium. You will see the gas bubbles which are forming, that will not be a uniform in size. There may be sometimes elongated bubbles will form, sometimes you will see very fine bubbles will form, sometimes you will see different shapes, like that oblate shape of bubbles will be, bullet shape of bubbles will be forming. So, these are these you will get that some pattern of that formation of that gas discretization in the continuous liquid. Even you will see that there will be a certain flow phenomena of the phases. There will be, you will see that if you get this what is that liquid flow, how the slag will be forming, and also whenever gas is flowing over the liquid, you will see there will be interface, that interface how it will be wavy there. So, this is wavy type of flow pattern. You will see some other flow pattern, like you will see that Chern turbulent, you will see that gas and liquid both will be mixing in certain way, that you will not follow a certain fashion of that flow, that all the molecules in the gaseous and liquid, you will see it will be arbitrarily mixing in the column, and there will be formation of circulation cell inside the column, and then you will see there will be a certain manner of that flow, that type of, it will be called as Chern turbulent, churn formation, churning phenomena will be coming. So, it is called that Chern turbulent flow. And other things, and also you have to know for that particular processes what amount of actually dispersed phase to be supplied in that particular process, that will be called as phase fraction. Or suppose if gas liquid flow is there, how much gas volume in the total gas liquid mixture, that will be called as gas volume fraction, or it is sometimes called hold up, gas hold up of the system. So, you have to know that phase fraction or gas hold up or liquid hold up or solid hold up in the particular column, that will give you the process output as a particular that efficiency. So, these things also you have to know how this phase fraction will be changing and how to control all those phase fraction. If you increase the phase fraction, what will happen? If you decrease the phase fraction, what will happen? Is there any pressure drop will increase or decrease if you supply more energy, more gas, or you will see there will be a formation of Chern turbulent condition. If there is a what is that bubbly flow, then whether is there any frictional resistance of the pressure drop or not. So, we have already learned that the frictional pressure drop in what is that single phase flow whenever it will be flowing through the pipe, but what about the frictional pressure drop when that more than one phases will be flowing through the pipe? That depends on the gas hold up as well other things, also flow pattern also. And friction factor, that friction factor it will be exactly the same as what single phase will give you in the pipe, but for two phase flow that friction factor will be different from that single phase flow. So, in that case you have to know that pressure drop, friction factor phenomena in this multi-phase flow systems. Even particle systems also, how these particles will be interacting with the other particles, how these particles will be interacting with the liquid, even gas, that phenomena you have to know. Even sometimes you will see when gas will be supplied as a dispersed phase of bubbles in the liquid, you will see some bubbles will be coalescing to each other, it will be joining to each other and making a bigger bubble. Some phenomena, some energy will be transferred, or high flow rate of the gas, you will see some gas bubbles will be that splitting into a smaller bigger gas bubbles will be splitting into a smaller bubbles. So, in that case you will get more surface area there, even coalescence if it is happened you will get less surface area there. So, this phenomena you have to know what you have to know the degree of coalescence, degree of what is that breakup phenomena of that particle interaction, particle bubble interaction, even particle droplet, even droplet interactions there. Because in that case you have to operate the process in such way that you have to have more interfacial area to a particular process output. And also whenever the phases will be flowing in another phase, you will see some wake will be formation in a turbulency condition, and then turbulence and the flow structure will be changed there, and mixing intensity will be there. Very mixing is one of the important actually phenomena of this multi-phase process, because that mixing sometimes it will hinder the process efficiency, sometimes that give the better process efficiency. That is particular process, that depends on that what type of process is there. Suppose if you want to transfer the heat, if you want to warm the some other phases, in that case you have to mix more that phases, so that the heat transfer will be from one phase to the another phase in more way. Even mass transfer operations, sometimes you will see gas liquid mass transfer operations, sometimes you have to have the more mixing there, so that the transfer of the mass from the gas to the liquid or liquid to the gas there. So, this type of things. Even distribution phenomena of the phases, suppose discrete phase or solid particles, gas particles or gas, they are distributing in the continuous liquid. How it will be distributed, whether all the particles will be same in size, or there will be certain ranges of the bubble that in the process, then that bubble size distribution or particle size distribution will give you the, that is process efficiency there. Even based on this multi-phase process, you have to actually scale up the processes from the laboratory scales to the industrial scale. So, for that you have to design the column in such a way that based on your experimental data, based on their geometry, based on their particle size, based on their configuration and the mechanical arrangement of the heat exchange, even some other aspect ratio, even some other similarity laws to be used to scale up all those processes based on the phenomena of the multi-phase flow, which is studied in the laboratory. And other operations like these are all actually hydrodynamic characteristics. So, you have to know these hydrodynamic characteristics to get or to analyze the process efficiency for the particular operations, and all those hydrodynamic parameters will actually may govern this, may control the process output there. So, that is why hydrodynamic characteristics is important to study before going to design of the system, design of the unit, even to calculate the output of the process. And then some operations you will see that some heat transfer characteristics is very important there. So, you have to know the heat transfer characteristics of the multi-phase flow phenomena also. Mass transfer characteristics, of course, if you are going to apply some multi-phase flow processes like absorption of the carbon dioxide in sodium chloride, sodium hydroxide solutions. In that case, you have to know the mass transfer characteristic, that how mass transfer, and that mass transfer coefficient, how it depends on several variables there. So, you have to know, even you have to do the modeling and simulation. For that you have to know the hydrodynamic characteristics, particle-particle interaction, friction factor, phase fraction, is there any wake formation or not, even is there any energy distribution, how it will be there, what will be the turbulency, all those things, distribution of the phases, even flow pattern of the systems there you have to know. So, based on which you can model or simulate, you can predict the flow phenomena in the multi-phase flow system. Now, to get the performance of the multi-phase unit, that you have to know all those things. First of all, like some design variables like a spark-jar, reactor geometry. In a particular column, if you are operating that multi-phase flow system for particular system, then you have to know the design parameters like spark-jar, reactor geometry, reactor internals, even catalyst activity, even size of the catalyst, concentration of the catalyst, heat transfer duty, even other, suppose some surfactant you are using, then what will be the dose of that surfactant, all these things you have to know. Even you will see some operating variables, sometimes you are allowing that gas, what will be the flow rate of the gas, what will be the flow rate of the liquid, what will be the, what is that recycle, if there is any recycle there, gas is back you are using, even liquid will be recycling, then what will be the rate of that recycle, and also feed temperature, composition, everything you have to know, catalyst renewal rate, pressure you have to know. So, these parameters, these variables you have to know, because all those variables will actually affect the performance of the multi-phase systems. Even the fluid dynamics and transport phenomena, if you want to know that what will be the bubble formation, how these bubbles are forming, what type of distributor will be used to form this bubble, even growth, coalescence, even redispersion, is what will be the dispersion phenomenon of the bubbles or particles, even what will be the size of that particles, what its distribution, gas hold up distribution, liquid recirculation, even liquid turbulence, or what is that back mixing is there or not, that you have to know. Even gas liquid area you have to know, mass transfer, effective area of the mass transfer surfaces, that you have to know. Catalyst recirculation, is there any agglomeration is happened or not in this gas liquid solid operations. Even settling characteristics of the solid particles, that you have to know. Concentration profile of the solid particles, how it will be distributed in the column. You have to know that liquid solid mass transfer, even flow regime, heat transfer, all those things you have to know under this hydrodynamics or fluid dynamics characteristics. And design variables, operating variables you have to know, even some thermodynamic variables also, like temperature, pressure, what is the temperature to be maintained, what is the pressure to be maintained, all those things that you have to know. So, I want to actually conclude here that for multi-phase flow systems, based on that single flow operation, whatever we have learned, the basic equations, governing equations, the same things also it will come in multi-phase flow systems, governing equations, all these things, how it will be derived and all those things. Though it will not be covered in this courses, but some idea, some phenomena of this multi-phase flow, basic understanding of that flow pattern we have to know, and based on which we will be able to develop our skills in the multi-phase flow operations in any particular real operations for particular processes to get particular yield. So, I would suggest you to go further of these books, that is written by me actually, that I have published these books, the hydrodynamics and transport process of inverse Pauli flow systems. You will get lot of information in these books, and you can follow for further understanding. Even as per your interest, you can go further other books also, like unit operations of the chemical engineering Jacob Smith, several multi-phase flow phenomena is described there. So, thank you for giving attention. Next lecture we will discuss about that multi-phase flow pattern, and with some video how that different types of multi-phase flow patterns are forming, and then you will get some idea about that. Thank you.